welcome to day 3.2 workshop. So we'll be learning prompt engineering with large language model today. So this will be the introduction to prompt engineering with generative AI. So what is prompt engineering? So prompt engineering with large language model involves crafting input prompts in a way that elicits the desired output from the model. So large language model like GPT-3 are powerful, but can be sensitive to how the input is presented. So effective prompt engineering aims to maximize the model capability and guide it toward producing output that align with the user's intent. So some key points to take note. So I'll be sharing 10 points. So the first point, which is clarity and specificity. So you will have to clearly define the task you want the model to perform. Avoid ambiguous language and provide specific details to guide the model understanding. A second point, which is example and context. So we always want to incorporate examples and relevant context within the prompt. So a large language model often benefit from concrete example that help them understand the desired output. A third point, which is task description. So we always want to explicitly mention the task you want the model to accomplish, whether be it translation or summarization. And so fourth point, which is experimentation. So you always want to engage in iterative testing. Try different variation of prompt to observe how the model responds. Experimentation is very crucial when it comes to understanding how the model interprets and processes input. So the fifth point, which is temperature and max token. So temperature controls the randomness of the model output, while max token limit the response length. So always make sure that you fine-tune this parameter to influence your generated content. The sixth point is context management. So for tasks that require context, you always want to manage your input context effectively, break down complex queries into small parts to help the model maintain a coherent understanding. And also, seventh point, which is prompt refinement. So refine nice can hear. Okay, nice. Sorry. Yeah, 7 point, which is prompt refinement. So refine prompts based on the model output. So you want to make sure that you analyze the response generated by the model and make adjustment to the prompts to achieve more accurate result. The 8 point, which is handling biases, you will always want to be aware of potential biases in the model response. So prompt engineering should consider ethical implication and also to take steps to mitigate biases in the generated content. So the 9 point, which is prompt variation. So you will always want to experiment with prompt variation to understand the model sensitivity to different input. So a small tweak in the structure can sometimes yield significant different result. The last point, which is domain knowledge. You always want to incorporate domain-specific knowledge into your prompt, especially if your task requires specialized terminology. So prompt engineering is an ongoing process that involves a combination of creativity, experimentation, and also a lot of fine-tuning. So by carefully designing these prompts, user can harness the power of large language models more effectively and also to obtain the output to better meet their needs. Yeah. So there are many types of prompt like open-ended, closed-ended, but today I just want to share 3 types of prompt, which is extractive prompt, generative prompt, and instruction-based prompt. So so basically, what is extractive prompt? So extractive prompt is a type of prompt engineering technique where the input prompt is extracted from the source text that the user provides. So instead of crafting a prompt manually, an extractive approach involves generating a prompt based on existing information. So as you can see from this code, so basically we um call this is a variable. So the variable name which holds the text extract the list of all products with more than 1,000 sales from the data set. So this prompt is instructing the data and analysis model what data to extract from the data set. So from here, we'll also call the data analysis model by passing in the prompt and the data set as an argument. So this function presumably um, presumably queries the data set based on the instruction in the prompt and returns the extracted data. So then it will print the extracted data. So generative prompt is a type of prompt used in the context of language model. So particularly in the realm of natural language processing and artificial intelligence. In this approach, users construct prompts explicitly that explicitly instruct the model to generate creative and original content based on the given input. So as you can see from this code, so again so this prompt is a variable that holds the text, write a short story about a robot that dreams of being a famous chef. So this prompt will instruct the language model generate function what kind of story you want to generate. So the third point, which is we will call the language model generate function and pass in the prompt as an argument. So this function will then generate the story based on the instruction in the prompt. And the last one would be like it will print the story that was generated by the language model generate function. So yes. So instruction-based prompt is a type of prompt engineering that that uh, so instruction-based prompt is a type of prompt engineering where the user provides a clear-cut command to perform a specific task. So it also gives a clear objective and wants the AI to execute a particular action. So from this example, again, so this prompt is a variable that holds the text, which is create an image of a two-story house surrounded by a garden in a watercolor style. So then we also have the image generation model dot generate prompt. So this model is so basically the prompt will be passed as a function into this image generation model, and then from here image dot show. So it will print out what um it will print out what you want to show. So moving on. So what is the benefit of prompt engineering? So there is 3 points, which is it increases accuracy of the AI generated response. The second point, which is it will provide more relevant answer to the prompt at hand, and also is more efficient overall and helps save time and resources. So we would like to discuss I would like to share 3 prompt engineering techniques. So it will be chain of thought prompting, tree of thought prompting, and least to most prompting. So, what is chain of thought prompting? So, chain of thought prompting refers to a technique in which a user guides a language model responses by providing a series of prompts that build upon each other, creating a coherent and involving narrative or conversation. So, this model is often employed to maintain context and continuity throughout the interaction with the model. So this idea is to link prompts in a way that each subsequent prompt builds on the information established in the previous one. So the goal of chain of thought prompting is to guide the language model responses in a logical and connected manner, allowing users to have more interactive and contextually relevant conversation with the model. So this approach is particularly useful when users want to explore complex tasks, sorry, have extended discussion, or when the context of the conversation needs to be preserved. So we use chain of thought to handle complex tasks that require step-by-step reasoning of information processing. So a chain of thought can guide the model through each stage, ensuring a more accurate response. And also context retention, such as the chain of thought allows the model to retain the context throughout the interaction. This, so each prompt is built on the information from the previous one, like this, and the example here. And also um, is also helping the model maintain a coherent understanding of the user input. So these are some small exercises that you can do. So basically, chain of thought prompting is like, okay, so the first one, which is write a detailed biography of a fictional character using the chain of thought. And second one, which is character creation. So basically create a basic profile for a fictional character. Can be John Doe, it can be like can be 40, then occupation, maybe software engineering, and like some brief background of John Doe. And the third one, which is chain of thought prompting. So you can expand the character biography using this chain of thought. Okay, so then we'll also have to review the biography and also refine them based on the responses generated by the model. So we'll also make sure that we want to pay attention to the detail of biography and how consistent it can be. So we'll also have to refine as necessary. Okay, so tree of thought prompting is is a technique used to improve the reasoning ability of large language model. So it's inspired by how human approach a complex problem, exploring different ideas and evaluating them before reaching a conclusion. So basically, I just give an example how tree of thought works. So there is 5 points. So the first point, which is central idea. So just imagine a tree trunk representing the main topic. Then from there will also branch out. So like from the trunk, so the branches extend outwardly, and these branches can represent subtopics, it can be related questions to solve the problem. And third point, which is exploration. So this large language model explores these branches, generating text for each one that might involve considering different possibility. So the fourth point, which is evaluation. So this large language model doesn't just blindly follow each branch. It also evaluate the generated text at each step to see if it's leading towards a useful answer. And if it's not, it will backtrack and explore a different branch. So the fifth point, which is search algorithm. So tree of thought will use search algorithm like breadth first, uh, search or like depth first search to systematically explore the tree of possibilities. So some benefit of tree of thought prompting is that it will give a more accurate answer. So like by considering different paths and also evaluating them, so this large language model can arrive at a more accurate answer, and also it improves problem solving. So it allows the large language model to also tackle the complex problems that require strategic exploration and backtracking. So lastly, which is least to most prompting. So least to most prompting is a technique used to guide and support learners. So especially those who need extra assistance. Maybe you're acquiring a new skill or maybe a completing task. So it focuses on providing the least intrusive help first and gradually increase the level of support as needed. So like like how it works is there's 3 points. So first point is always to start small. So maybe like the instructor will start by offering the least amount of prompting necessary. So it can be a verbal cue, it can be a visual prompt. So as so second point, which is increase help gradually. So if okay, the learner is struggling with the initial prompt, then the instructor will then provide a more explicit clue. And I mean, this explicit clue can be a full demonstration or just breaking down the task into smaller steps. Then the last one, which is because in the ultimate goal of least to most, you just want to fit the prompt completely as the learner understands and gain mastery of the concept. So the idea is to provide a temporary scaffolding that can be removed once the learner can perform the skill independently. So least to most is beneficial for situations like, okay, maybe you're teaching a new skill. It can be used to learn new skills like writing or math problems, and it will also improve task completion. So it can be used in general to help anyone complete tasks more efficiently, like by providing initial guidance and gradually reducing the support as needed. So now I will pass the time to Samuel to share with you more about to practice.
Hey, thanks, Jasmine, for the insightful sharing. Wow. Okay. Now I'll be doing the I'll be doing the exercises for. Can you hear me, right?
Yeah, I can.
Okay, so I'll be doing practicals, which is the chain of thought exercise first. Okay, give me a sec. Okay, so chain of thought exercise. So how are we supposed to code it out all this theory that we discussed, Jasmine has discussed about? So chain of thought actually forms the basis of all the prompting because you need chain of thoughts first, and then before the chain can be elaborated to trees, and lastly the least to most is like you're building something gradually upwards. So chain of thought is usually the initial way we can work towards whenever we do ChatGPT. ChatGPT tries to follow our responses of the previous response. So this is the code for it. Again, we are using in that sense we're using a random module and then a prompt response mapping where each key represents a prompt and its value, the outcomes associated with that prompt. So this loop will iterate through the keys in responses to the dictionary, and the random response will be generated accordingly, which we could so go to our Google Colab. Okay. Although I already have this done with me, but I will restart because there are some errors here and there that I tried some of the things. Okay. Okay, actually this error is just keyboard interrupt because I stopped the code for a while. Okay, anyway, we'll go through the first one. So chain of thought prompting is the first exercise. You'll first I'll just give you all like 30 seconds to open up Google Colab. Okay, assuming that you've opened up Google Colab, you shall get started. So at the chain of thought prompting, we just import. First of all, we import random. Okay, so it tries to use the random import. So right, it will try and do stuff with that. Okay. Generate response given a prompt. So the responses is a dictionary that saves a few key value pairs. So we're gonna first very simple. We're gonna do hello. Okay, how are you? Simple prompts like hello, how are you? Don't have to be capital letters because we're gonna turn them small letters anyway. Okay. Weather. And lastly, goodbye. So whenever we have a key, right? And then we have like values. So hi there. Hi there is one of the responses to that. You can respond hello as well as greetings. Oops, apologies. We haven't done yet. Okay, greetings. And don't forget to add a comma because it's a common mistake. Okay, now how are you? You see the AI actually could detect like what I want to type already. So pretty good. So let's say I'm fine, right? I am fine. Yeah, it's very close enough. I'm fine. Thank you. So response, I'm fine, thank you. Response number two, doing well. How about you? As well as all good. And comma, thirdly, we have weather. The weather is nice today. I heard it's going to rain later. And lastly, it's sunny outside. So it's sunny outside. Now we're not done yet because we're left with the goodbye one. So the goodbye response could be when it says goodbye, it will just respond that goodbye, goodbye, or see you. I will share the see you later and take care. And then we close the bracket. So you see, every question from itself has its own responses. And then we just run through a for loop. No? So for key in responses with the key in the prompt, but we lower that prompt, it's also lowercase in the first place. So dot lower, we return the random dot choice or random dot random integer of or just random a choice of any of the responses. You could say it's a bit so-called hard-coded lah, honestly. You're just doing a random choice based on all these, and then it generates you the answer. Then if it gives, if it tries to, you try to ask something that's not is not seen before, it's like I'm not sure how to respond to that. Okay, so let's give this code a try. So this could be chain of thought. Okay, and then it tries to generate response function that can be used interactively, and then the continuous prompts are the user for input until the exit is typed. So now we try the user input is input user. And then while the user is just handling a user validation. Like user validation is like exit. So exit is like when you type exit, then it will just exit. If not, you just keep asking for your response. So generate response. So we need to define that generate response function. So generate from user input, print bot. as well as response. So input equals to input bracket user. Okay, then you try this code. So let's say like user wants to type something like hello. To try and convert the small case and then you just hide there. It's literally just hi there. How are you? Then I'm fine, thank you. So weather. The weather is nice today. So let's say it's the weather nice today, right? I think it wouldn't be sure the weather is nice today. Okay. Okay, anything good weather is like the weather is nice today. How is the weather? Weather is nice today. Okay. It simply just takes this, it keeps taking this. Is it going to rain later? I'm not sure how to respond to that. Sadly, it's just a bit coded. So like, so goodbye. I'm not sure responded by like, if I say goodbye in like they will say goodbye. Okay, this is an extremely simple demonstration. Okay, but it also does not exactly have chain of thoughts. It's just very in a sense hard coded lah. But you could also tell that how you could actually piece up like a chain of thoughts to in a sense if you look at look at Jasmine's previous slides how it was asked like give me a story and then I ask different prompts of the story, different parts of the story, and then making that things all linked together. Okay, but this practical is an extremely simple one, so we don't press keyboard interrupt, we just press exit. So exit, we exit gracefully without the error. So very simple. Actually, this one is the actually the transformers. We are using actual transformers from now on. So given that we hard coded the first chatbot, okay, now we will do something more exciting. Now from transformer, so that is all my documentation will be text, three hashtags using uh transformers. Okay, from transformers import GPT tool and model is just a GPT tool model and its own tokenizer, which helps us to arrange to different separate words. So defining a generate response given a prompt, model as well as tokenizer, and the maximum length. So what does maximum length represent is the total maximum length equal maximum character length of that generated response itself. Okay, so input ID, right? It's the ID is the tokenizer dot encode. So again, we covered how tokenizers could do the encoding. So we are just using a built-in tokenizer without really explicitly coding a tokenizer. So it's being done for us really. So we just need to say return tensors. Again, you don't have to cover what this means. It's just that it's a way to return tensors. So what does tensors mean? They actually made matrix in your assuming you learned that in your secondary school. Tensors are like matrices for you to multiply. So 1D tensors are actually single columns. Okay. Then 2D tensors are like tensors within a tensor. So that's like two. And 3 tensors are having like more, basically the more dimension of tensors, right? The more nested the tensors are. But we won't cover that again. So just let you know that tensors are a way for us to do to return our input data. So model generate is where the model really generates, okay? Input IDs. Input IDs refer to what we have done in tokenizer. Max length equals max length. Again, you could set it to like 100 or whichever variable that we define. Okay. But then because it's a parameter here, so you see, so it's max length. We don't hard code the max length. So max length equals max length. We don't hard code it. Number of beams is just that beam search method that 2.1 has covered. Repeats. N-gram size. N-gram is the we've covered in 2.1 also. So n-gram means this two n-gram equals 2 means we are having bigrams. Is analyzing bigrams without repeats, right? So bigrams refer to like so I love generative AI. So I love generative and generative AI are bigrams, right? So n-gram size equals to 2, but it's trying to tune that parameter itself of n-gram to know repeats of it. Okay, now we're going to cover this very more abstract concept known as top K. So top K refers to the sampling of how probable, how what is the top likely probable tokens, or rather the characters or words in this case that we want to generate. So top K equals 50 means the top 50 tokens that we want to generate. Okay, let's say if the less the top, right, it will consider less tokens. But if this number increases, we're going to consider more things. So it's like saying I'm considering the top 3 students versus I consider the top 10 students, right? So the top 10 students, more students will be considered, and then and be randomized among the 10 students to select the student that I want to select. Okay, but then the top 3 students, right, there will be less selection between that 3 students itself. So that's an example. Like since I thought the first thing I thought of top K would be like, oh, I'm selecting students in the class or something like that. Okay, so top P is like 0.95. That 0.95 is just a probability. Again, we won't cover in depth what it is, but it's just a probability kind of a parameter, as well as temperature. So temperature refers to how likely something is gonna like generate. So the higher the temperature, the more likely something is gonna generate, right? The lower temperatures means like those who are obviously gonna generate is just gonna generate. So I could show you a picture of, I really prepared something like this. Okay, generate top K, no, temperature. So temperature equals 0.2. Obviously, apples is the clear winner. It will generate apples. But then if temperature increases, right, you start to see that more unlikely words are going to be more likely, known as a P of X, the probability of it happening. So we learn in computing math that this is the probability from range from 0 to 1. Or rather, you could say probability of X, so P, though denoted P, bracket X refers to the input. So based on the input, what is the output? So input, output. Okay. So when temperature equals 1, you start to see that things that are very clear winner, like they start to decrease. And then those less of a clear winner, like onions, pens, and shoes, are they starting to increase more. And then by the time we hit a very high temperature, everything is almost the same. Right. So you consider more unlikely words that are more probably. So this increases creativity of how it generates things. So I hope I give a good example of temperature variable. Even this one, you see when temperature is set to 1, things that there are more like things that start to tokens start to generate more, as well as like even that 20, there are more higher bars of other words as well. Right. And behind all this is really is a very complex math algorithm. Okay. So now we're going to do generated text, right? So equals to tokenizer dot decode output index 0 and the skip of the special tokens equals to true. Then lastly, we return the generated text. So generate response, return generated text. Okay, then we will run this code. And next we will loop this main function. So similar to how we are doing this user input, right? We are now looping it, okay, into a df main. So df main model equals to GPT-2 LM model dot from pre-train. bracket GPT-2. And then tokenizer is GPT-2 tokenizer dot prompt to train GPT-2. And then we now have the user input. So user input is the input of the user. So this one definitely we must give it one. And then conversation history is the user input. So user input is being saved in the conversation history. Okay. And lastly, while the user input got lower, okay, user input we always convert lower for consistency. And then if the user did not type an exit, you just keep generating. Else stop. Okay. Generate response. Oops, spelled wrongly. Generate response. Conversation history, comma, model, comma, tokenizer. And then printing that response, will output it as a print. Bot. Okay, we find space this, no, don't have space it, because it's comma. So bot, comma, response. And then the user input will input again. Again, user validation and all that conversation history concatenates with the new line and the first user input. So it's like a history variable that allows us to concatenate whatever is going on into it. So new line plus user input. And lastly, the AI is smart enough to detect that if the name equals main, response equals to generate response. If magic method of name is actually main. And then we simply use the main. So generate response would have statements are separated by new lines. Okay. This should work. So what we're essentially doing is getting the user input to work, and it won't show us which code is which line is running. So it's running user input, input user. So let's say hello. You try to generate hello. Thank you so much for taking your time to read this. I hope you enjoyed it. Advertisements. What's that? Well, you could maybe just say, what is your name? It's gonna be a small letter anyway. So what is your name? My name is my name. My name is my name, and I am a student at the University of Texas at Austin. I graduated from high school with a degree in computer science and computer engineering. Whoa, double degree, computer science and computer engineering. Okay, my goal is to become and it's cut off there. Actually, the number of length of sentences is actually quite it's kind of short. So if you want to like upload and check the length of sentences, it's just essentially just curious. What is the length of the sequence? Yeah, I'll just start exit for now. Exit 188. Okay, that's not too bad. That's not too bad. But you could feel free to explore on your own if you want to make this like longer inputs, longer like in that sense, longer responses. But it tries to do just chain of thought lah. So like you even use the examples of the okay examples here. It's like chain of thought. Tell me a story of once upon a time Once upon a time, there was a brave knight. You will try to like link a story to it, and it's like the prompt. It's like in the field of battle, it said to me, "I am knight, but not one of you," and I said, "Well then." So this brave knight lived near a peaceful village. Can you describe the village? And he tries to say the village was very peaceful. Uh, the village was very peaceful, the people were friendly, and there was. Okay, interesting. So again, chain of this, how chain of thought could really work in that without hard coding it using transformers. So I hope you enjoyed this mini practical that you prepared. Okay, now we move on to the next one. Now, tree of thought exercise. We'll just start exit for now. We'll stop playing with this. Okay, so tree of thought exercise. To install, again, we already loaded this library, so we could actually skip this whole slide itself already. See, it's already loaded in for us. Not really. Is it? Yeah, it's already loaded for us. DF main. Only one call. When calling main, then you will do it. So we'll just copy this. In that case, copy this 2 lines of code. Uh, code, model tokenizer, model. Port. Okay. Then defining a tree of thought prompting. So right, the tree of thought prompting is like a creating function taking input and prints responses to display text for each layer and branch combination. So actually, this is one of the more complex ways of prompting the GPT. So like EF generate complex tree of thought prompt, given its prompt, its model, its tokenizer, the same thing lah, huh? Maximum length is 150. Oh, number of layers is like each layer in the tree. You could think of tree of thought as like your data structures and algorithm, you know. It has it consists of a tree that has leaves and branches. So the branches refer to what are the possible pathways that the prompting could happen. So tree of thought responses is an empty empty list. Then for every layer in the range of 1, comma, number of layers plus 1, layer responses is actually blank. But then we're going to populate this list later, so we'll do a for loop in the for loop. Again, within each subtree itself, we are trying to get as much info as possible within the subtree, and then we're going to go on to that layer. So every layer is subtree, and every layer is subtree, every layer is subtree. So you will keep offsetting itself by 1. So you start from not index 0, but index 1, which is the first tree, instead of index 0, like what we usually do. Number of branches plus 1 refers to how we offset without excluding the last branch. So this is the important step now. Okay, so for this one, layer branch prompt. So I always like to use layer plus string layer. So you could format this in however way you want, but personally I like to use concatenation. Okay, so comma branch plus str branch, because they couldn't really output out like a concatenation of string and integer. So you got convert to a string and then output it. Plus dash plus from. Okay, great. Lastly, we do input IDs is the tokenizer. We'll try and encode again. Branch from and the return answers equals to PT. Okay, then we do outputs. Model.generate is outputs, input ID. Max length is the maximum length. We don't hard code it, so just like that. Number of beams is 5. Okay, we also explain the n-gram concept. So like we just and number of n-grams is 2. Now it's too long, so we just backslash enter to show the next line. Top K is 50, top T is 0.95, and temperature is 0.7. And then close the bracket, and we are done for that line. Oops, new extra bracket. Now we save it as generated text. Tokenizer dot decode, so encode then decode outputs index 0, and is able to have the parameter to for us to skip special tokens. Okay. Lastly, layer of responses will keep on appending for every for loop. And that is how the empty list is populated over time. And lastly, after we populate finish already, right? I think finish, then just TOT responses dot append layer responses. And then returning that response itself. So assuming that you all got it, okay, it's simply just running through 2 for loops, a nested for loop, like the description here, displaying text for each layer and branch combination. And lastly, generative responses are printing out, displaying for each layer and branch combination, and ensures the responses are tree-like structure. Okay. Lastly, we go to do user input. So user input is only an example exploring a dungeon. Then responses is the generate the complex tree of thought from given user input model tokenizer. The number of layers equals to 4, as well as the number of branches equals to 4. Then, oops, I haven't complete that yet. Okay, but it's not defined. Then run this one first to define it. Then we'll now output the responses in for loops. So layer comma layer dot layer underscore responses in enumerate in regards to how we want to give assign each response a number. So like enumerate responses 1. It's like you're just printing a for loop, no? Branch comma response in enumerate layer responses comma 1 print layer comma layer comma branch. So layer first, and then that layer, then branch first, and then branch, and lastly the response. Add some comma first. Some comma first. Response to give us a response. Okay, great. Very good. you just output every single leaf that is in that tree itself. I could even search up while waiting for the things to work. I could search up for how do I show it the tree of thought prompting image for you guys. So it looks something like this. Okay, it may not be shown in big pictures, but if you really want to know, it's really like this. So input, so the tree, and then I'm printing out this like particular like sub tree within tree within a tree, tree within a tree, and print. And lastly, after doing for loops to print this, I get an output. Okay. So what about like image of a chain of thought? Yeah, you could use this example on your free time. Okay. Actually, it's not. I don't think it will be too hard. Yeah. So I hope you enjoyed this simple practical. And lastly, while waiting for this to load, you could look at this the most prompting. Okay. So for this the most exercise, right? We have again a specific PDF just for that itself. So we're going to go back to our code. Actually, I already done the code already, but I'll just do it again. So PDF the generate list to most prompts. Right. So prompt model tokenizer its length is 100. Okay. These two most responses is actually first an empty list, and we want to print a for loop for I in range, comma, the length of prompt dot splits plus 1. And then you do a partial prompt is the whole the joining in terms of spaces, so dot join prompt dot split and with the square index of I. Okay. Then input IDs. We have the tokenizer dot encode the partial prompt and return tensors. Again, we do PT. Okay, basically it's the same thing. It's a bit repetitive by right now. You'll be doing this a third time. It'll be just generate after I encode, generate, decode. Yeah, yeah. Max length equal to max length. And no repeat. Okay, no repeat. And grams times 4 then divided. Okay, equals to 50 top P minus 0.95, and temperature variable is 0.7. And then we do a generated text. The tokenizer dot decode its outputs index 0. Yeah, let's copy that over actually. Tokens equals true. And lastly, remember we had declared empty list, so we populate the list. Basically, just save our answers. So generated text. Okay, we are officially done because we just need to return. It's the most responses. Nice. Okay, this is taking very long to load, but let's be patient. While waiting for this to load, we could do others. So first we will describe a beautiful sunset. So user input equals to describing a beautiful sunset. Incomplete input. Oh, it seems like the responses are like dotted, like dot. Okay. I guess we could always try to run this later. But for now, it's just, I think, very long. Okay, no worries. We'll first try defining this first and describing a beautiful sunset. And then responses generate the list to most from user input model and the tokenizer. And for I, comma, response to enumerate responses, comma, one print response, comma, the other way around because response stri and that response. So response 1, response 2, response 3, you just generate like that. So you see, it generates first response, describe yourself and all that. So right, oops, this spelled it wrongly. We will try again. Tokenizer is not defined. Tokenizer is I spelled it wrongly. So tokenizer is wrong. Okay. I just want to show you a good sample of how this is supposed to really run and work. Okay, so regarding the tree of thought, right? I think it was just very long lah, but that's my guess. But that when we try and run it on our local site, actually this is what we got. So layer 1, branch 1, so exploring a dungeon, and then searching for a treasure chest. This will be where you all find the items needed to complete the game. You can find them all in one place, or you could go back to main menu and select the item and click a search button. So it's a very it's like searching for a treasure chest and then finding a treasure chest, searching for a treasure chest. So you see the branches go deeper and deeper across. And then exploring a dungeon is the first dungeon of the game, so the left side of the map. It goes through that series of trees and it tries to go deeper into describing finding a treasure chest. If any questions, okay, then not tradable or marketable has a 10% bonus to attack speed with any weapon, etc. Okay. So this is a bit like outputs of this whole thing. So now it's successfully outputted all the responses. So response 1, describe yourself, what is your background, what some of things you've done in the past. And you're trying to this leads to most prompting. It works a bit differently. So it's like you're doing very generic words, asking generic questions like what is your background, what you do, what have you done. I always been interested in learning about the world around me. I've been fortunate enough to work with a lot of great people, and I'm very proud to be part of that community. It's been a long time coming, but I think it's time for me to get back. Response to describe a person or thing that is important to you. What do you feel when you don't know what you're talking about? What are things you say? And tries to have also a response tree. So response tree is like a woman who is beautiful is one who has great sense of beauty. Every person will look beautiful. So it's a bit repetitive lah. It's the more not great that sense of beauty in the way the pleasing the eyes of the beholder. And you're asking a more specific question along the way. And then lastly, a beautiful sunset. So the explanation for this is that okay. The explanation is that uh the context is prompt one tells me to describe myself. So I will focus on the capabilities and purpose. Okay. And then it tries to require the least specific information from you, and it allows you to answer in your own way and share what you feel comfortable revealing. And then I gradually increase in the specificity, and each subsequent prompt builds upon the previous one, becoming progressively more specific. Where prompt 2 now asks about something important to you, while prompt 3 will focus on a specific type of person, a beautiful woman. And lastly, it narrows down. Prompt 4, right, will narrow down to a particular scene, a beautiful sunset. And then this increased guidance is like, it becomes more specific, so it provides a guidance to what aspects to describe, and it suggests like characteristics of beautiful woman, and then a prompt 4 mentions the time of day. So this strategy helps you to actually refine your response to provide a more detailed information with each step, and allows you to start with a broad idea and then zoom into specific details as the prompts can guide you. Yeah. So that will be for our section for this prompting exercise. Okay, so the rest of all these slides, right, from slide 32 onwards, right, they are actually optional self-study. Okay, but since we finished quite early today, so now it's like around 2:30, right? We won't be covering the gun anymore because it's optional. It's totally for you to self-study, but like just to tell you that it's very doable lah. Okay, it's doable because it's just a discriminator and generator, and then it tries to like see how the generator could mimic to treat the discriminator that is a real image. Yeah. So these are all the slides. If you just pause the recording to like view them. Okay. So the applications, and then it tries to touch into the code for all these so you try to generate things like the numbers and using training the models, generating samples for you. So you see it after the epochs, right? After training, it will generate more clearer numbers along the way. So at first it's just very random, and then suddenly you're just able to come up with specific clear images. So this is what Gun could do to a simple handwritten data set, given the data set that is being fed into, such as this is known as MNIST. Some people call it MNIST, but I prefer it MNIST. So it's a handwritten data set, very simple. It has pixels, and then you just have to convert the pixels into numbers and then train the model, and you get outputs after these epochs. So that's how generative AI could work in terms of images. And now you can scan for the attendance. So I'll give you all like 1 minute to scan the attendance, and afterwards we could end the session. Thank you all.